All right, so tonight, let us figure out some fun Hackerrank stuff. So this one, they marked as easy, but when you have symmetric difference in the title, I have a feeling it's not going to be that easy. So let's see how it goes. Today we're learning about new data types. New data type, sets. Have we talked about sets? I think we have. They're an unordered collection of things. Unique things. Those are the things to remember. It's an unordered collection of unique items. So if you try to put this, like the number 3 in a set twice, it only stores it once. If the inputs are given on one line, separated by a space character, you split to get the separate values in the form of a list. Yep, we knew that. A.split, then we get a list of 5, 4, 3, 2, 1. If the list values are all integer types, use the map method to convert all the strings to integers. Okay, we can do that. We haven't talked about map, but we'll walk through that. Sets are an unordered bag of unique values. Hey, that's almost what I said. A single set contains values of any immutable data type. So creating sets, my set. So here you see the, oh, that's really small. I'm going to make that bigger. Here we go. Can you read that better? My set. So instead of parentheses or brackets, it is squiggly brackets. Directly assigning values to a set. Or I can create a set with a keyword set. Or I can pass a list to the set function. It creates a set from a list. Then I can print it out and I see A, B, because this set had A, B. Modifying set. Oh, this is teaching us how to use sets too. This is kind of cool. Modifying sets. We can add something. We can add something here. I am adding one thing. That one thing is a tuple with the values 5, 4. So it's not two things I'm adding because the add function has the parentheses, but inside that I'm passing a tuple. Use the update function. Update only works for iterable objects. So iterable objects are things like lists, sets, tuples even. Anyway, and I think it's going to add every element in that list individually into the set. That's what it looks like. So yeah, so this one's a list. This one's another set. This one is a set and a list. Notice they're not in extra parentheses, so it's not a tuple, but it is a 2 parameters. Then I can discard or remove. Both discard and remove functions take a single value as an argument and removes that value from the set. If the value is not present, discard is nothing, but remove will raise a key error exception. Okay. So if I don't care if the value is already in there and I want to try to remove it anyway, I'll use discard. Because if it's not there, it won't throw an error. If I care, then I will use the remove function, and it will throw an error if it's not there. Cool. Set functions. A, okay, union is the function. So A dot union B, value exists in A or B. That's not a union. Oh, yes, it is. Sorry, that's a union. Intersection is what I was thinking. So the values that intersect A and B, and then difference is the ones that do not, that exist in A but not in B. Okay. Now we're talking about symmetry. The union and intersection functions are symmetric methods. A union B equals B union A. Makes sense? A intersect B is B intersect A. A difference B is not equivalent to B difference A, because the difference values exist in A, so we can think of the outside one, but not in B. All right, now we're getting to our task after that long introduction of sets. Given two sets of integers, m and n, print their symmetric difference. What? Their symmetric difference in ascending order. The term symmetric difference indicates those values that exist in either M or N, but not in both. Print the symmetric difference. Okay. Input format, M, N. Oh, this is how many. We don't care about that. Output the symmetric difference in ascending order. Okay. Oh, I see. Okay, cool. All right, so here's our code. I don't know what the heck is happening. So the first thing I'm going to do is figure out what my input is. And A, well, let's see, A equals, is it input? Input. Print A. Run code. Your output 4. Okay, so I got that 4. So I know I'm going to have 4 values in there. So the first one is going to be number set A equals A. Then, there we go, let's do it like this. Set A string equals input. Number set B equals input. Set B string equals input. The ones I really care about are my set A string and my set B string. So what I printed out was 2, 4, 5, 9 to match that, 2, 4, 11, 12. So I have my input right. I did that super quick. So the input is going to be the first number tells us how many elements are in the first set, which is the next line. The third line is a number. It tells us how many elements are going to be in the third set. Or sorry, the second set. Third line tells us the number of elements in the fourth line, which is the second set. There we go. That's a way to say it. Okay, so first set equals set set A string dot split on a space. Second set equals set set B string dot split. This should give me the 2 sets. What I'm doing, this split function gives us a list. Then the set, when I pass a list to the set function, the return value is a set with the elements that were in that list. Okay, so I can run that again. And now I have my 2 sets. They're strings, and I think I have to do some mathematical operations. I think it wants me to do mathematical operations. So it had a map function here earlier. Here it is. List map. Okay. So kind of like list comprehension, this map function, let's focus just on the map function. The way we read this, we look at the map function. The first parameter is a function. Okay? Int is a function. I can cast something to an integer like that. If I can't pass a string to the int function, I get the integer value back. And then the second parameter is a list, or a collection of some sort. In this case, it is a list. So every item in that list will be passed to the int function, and the result will be a new list. So I want to do that with my strings. So let's take my set A string, and I will make my set A list equals map int set A string split. Set B list set. So for every string value in my first line of second line of input, the first set, I'm going to make a list for all the string-based integers, pass them all to the int function, and my return should be a set of integers, or sorry, a list of integers. And then I want to make those into a set. So I'll still pass that list to a set. So last time I ran this, I got a set of strings. Everybody see that? This time when I run it, I should get a set of integers. And I do. How do I know it's a set of integers?
There's no more quotes around it.
Perfect. No more quotes. Okay. Now, we got to figure out what the hell this thing's asking us. Oh. Okay. I see what they're asking us. The symmetric difference in ascending orders, one per line. So symmetric difference. That is the difference of the two sets. So let's see what happens. First set, oops. Second set, diff. So from the first set, which is line 2, I want the difference from that. So everything in the first set, but not in the second set, is what this difference will show me. So actually, I'll still print those out so I can see it. Set 1, set 2, things that are in the first set, but not in the second set. All right. Okay. In my output, I want 5, 9, 11, and 12. Okay, so I have 9 and 5. How do I get 11 and 12? And how would I do that?
Can't you just do the same thing you just did, but switch them? And then put them together?
Yep. I think I can cheat. Say diff1 plus equals. Whoops, let me print that out though. No, I guess I can't do that. Lame. Oh, I have a function. I have a union function. So I'll just do that as my diff2. Then my output set is diff1 union diff2. Print union set. Oh, union set is output set. Yep, my bad. So now I should have all 4 numbers, 9, 11, 12, and 5. 9, 11, 12, and 5. Awesome. Now how do I order them? It's easy. I wonder if I can do ordered like that. I may not be able to on a set. I may have to make it a list first. Yep, no, I can't ordered. Can I ordered? I don't think I can order a set. Sorted, because that's why it's not ordered, it's sorted. There we go. I just had to sort them into numerical order. So I sorted my final set and printed the value. Maybe. Oh, there we go. They all passed. Go team, go. That wasn't that bad, was it? Nah. All right, let's do another one. That was fun. Next challenge. Oh, let's see what they give us next. Oh, lordy. This one's medium. Should we try a medium? We should try a medium. But if it gets too complicated, I'll bail us out. Meaning I'll quit, not like I'll get it done. I'll quit. All right, there's an array of n integers. There are also two disjoint sets, A and B, each containing m integers. You like all the integers in set A and dislike all the integers in set B. Your initial happiness is 0. For each I integer in the array, what does that thing mean? Does that mean if it's in? Yeah, I guess that means if it's in. So if I is in A, you add 1 to your happiness. If I is in B, you subtract 1 from your happiness. Otherwise, your happiness does not change. Output your final happiness at the end. That seems super easy. Why is this going to be hard? All right, so I'm going to need this. Sample output 1. Okay, so I'm going to put this as a comment real quick, just so I remember this. Oops. A is +1, B is -1. We start with happiness of 0. Okay. Oh, that's not what I wanted. Input format. Okay, N and M are the sizes. Okay, so M is 3. Sorry, N is 3. N is the number of integers in my set. The next M is the size of sets A and B. Then there's A and B. Got it. Okay, let me write that down again. Oh, I think I already did. N, it didn't copy paste, that's why. N and M. Okay, so first line input, second line input, okay. N and M separated by space. So I can NM equals first line split space. Okay, cool. Then I can do my numbers is second line split on a space, but I want them as integers. What was the function I used to turn them all to integers? Int, yes, but int had to be called by, or what? Then what is the other function they used? Map. Okay, so then I should do that a few times. So good numbers equals that. Oh, I'll fix this in a second. Bad numbers equals that. Fourth line, third line. And just to make sure, I'm going to print n, print m, print my. How's that look to everybody? Anybody think that's bad or wrong or something wrong with that? No? I think it's okay. Let's see what happens when we hit run. Map object. Oh, did I have to list it? Did I have to do that? I don't remember. This is what I get when I just copy and paste code. I don't actually remember what it did. Okay, that worked. Okay, cool. So 3, 2, 153, 31, 57. Easy. Now what? In the end, I have to print happiness. That's the only thing I'm allowed to print. So let me get those definitions again. For each integer in the array A, I add 1 to my happiness.
So we want to do like an if statement, right? If the number
We'll come back to that. How do I tell if a number, if an element is, or if an item is in an array, in a list?
if it's in the array, the A array.
Yep.
Then we add 1 to happiness.
Yep. But how do I do that Pythonically? Fill in the blank.
In.
Thank you.
Sorry.
It's all right. Right?
Yep.
Right? What is number? How do I get number? I have to look at every number in my numbers. How do I do that? Thank you, John. 4x in my numbers. What? What did I forget?
We had to else if, or yeah, you have to indent them too. But would it not be else if or?
That's all I need. Because if it's in good numbers, great. If it's in bad numbers, subtract it. I know by the definition they're disjointed, meaning there's no overlap. That wasn't a medium. That was pretty easy. So look at every number in my list and see if it's in the good numbers. And if it is, great. I add 1. Yes, I could have done an else if here if I wanted to. That'd technically be more efficient. Let's see what happens. But we're about to make this one a medium now, because we're gonna redo this with list comprehension. Oh, what?
I was wondering if we're supposed to do else do nothing. Is that important or no?
It's not now.
Okay.
Okay, and so when I get a timeout, it tells me I'm super inefficient in my code. Why am I super inefficient in my code? I'm mapping every value in the integer and into a list. Did I need to make it a... I didn't need to make it a list. I don't think. Why did I make it a list? Oh, because a map object. Shoot, that's right, I did. How can I make this way more efficient? Oh, I totally have an idea. Okay, the reason this is inefficient. This line of code, the length of time this takes, grows as the list gets bigger. Right? So if it's 2 items in the list, it's really, really fast. If there's 2 million in the list, it's slower. But the slowness is a linear relationship to how many items are in the list. That's a good thing. That goes the same for these. Here's the problem. My for loop is fast because I'm only iterating through my numbers once. Then to see if X is in good numbers, I have to look through the whole list of good numbers. Then if it's in, to see if it's in the bad numbers, I have to look through the whole list of bad numbers. If those lists are really, really long, say I have 1 million my numbers, 2 million good numbers, and 2 million bad numbers, 1 million times I have to look through 4 million numbers. So the bigger those numbers get, I start multiplying how long it takes. It's no longer a linear relationship. It becomes an exponential relationship. So the bigger they are, the slower it gets. We should talk about that in class. We'll talk about that in class soon. So we need to figure out how to make that more efficient. How can we make that more efficient? Oh, I totally know how we can make that more efficient. So let's try something. Isn't list comprehension faster than a for loop? It may be. Let's figure that out. So we're going to try something. I want to make 2 lists. The first list, I want to have either 0s and 1s in it. Yeah, 0s or 1s. So here's what I'm thinking. Bad or good scores. Is an array. Where I want 1. Oh crap, see now I'm forgetting my list comprehension format. I do this every time I do this. Here we go, letter for letter. There we go, that's what I need. Letter for letter in human. Where'd I go? Where'd my Hackerrank go? There it is. Letter for letter in humans. Okay, 1 for letter for X in my numbers if X in good numbers. So I want a 1. Yeah. If the number is in good numbers. I don't think this will be faster, but it might be. So I got 2 1s. So I'd add 2. So I can actually sum that good scores. Then I want to try that with the bad scores as well. But instead of 1, I want a -1 if it's in bad numbers. And okay, so that's going to give me the right answer. What I'm curious about is, will this be faster to pass the test cases? Okay, it's still slow. But that was going to be my second attempt. I think the problem is I still have to iterate. This is my problem. X in good numbers. That's the thing I need to avoid. X in good numbers. Because I'm multiplying the number in my numbers times the number in good numbers. That's the problem. So that's called, there's something called big O notation. It's a complexity notation. Big O1 means no matter how big your collection is, it always takes 1 unit of time. If it's big O n, it means that is a linear growth between the number of elements in that collection. Linear is okay. Exponential is when it's bad. And this is bad because this is exponential. So my goal, I think, is to make this truly a linear lookup. And the only way I think I know how to do that is by creating a data set, a data type, that accessing the elements in the data type is a big O1 operation. And that is a map. That is a map. No matter what, I have to do this. I have to turn them into a list. I think. I'm pretty sure I have to turn them into a list. So let's try something. So a map in Python is a dictionary. Right, we've talked about dictionaries. So my scores, let's do a dictionary. And this may be slow, so this will be my first attempt. For X in good numbers, my scores X equals 1. For X in bad numbers, my score is -1. Then I can do 4x in my numbers. Happiness plus my scores x. So if my number in my numbers list is 3, if 3 was in the bad list, it would be -1. So this might be better. So does everybody get why this is not that exponential relationship? because that linear relationship now I'm doing 3 times, so I'm doing it to set up this map. But then that last time, that thing that kills us for x in good numbers or x in bad numbers, that's the part that's killing us. I'm avoiding that because I've pre-set up all those numbers with a really fast way of getting those values by using a dictionary. So this is more memory intensive, but less CPU intensive. So it's going to be more stuff stored in memory, but less operating, like CPU time for calculating or searching that collection. If this doesn't do it, holy crap, runtime error, what? Those worked. How freaking big are these numbers? Okay, what are these hackos? How many hackos do I have to spare? I don't know. The problem now might be that I'm doing this iteration and this iteration. Int map list. So let's try making these two a little faster and avoiding these. So let's say I want my scores here because I like that. String in third line dot split. I feel like I have to do that. My scores x equals int string x equals. Do I even have to be doing this integer conversion? I don't have to be doing this integer conversion at all. That'll be our last attempt. Equals 1. So now I'm only iterating the line once instead of twice. Make sure it still works. Still worked. I didn't know they were this picky on time. What's that?
So I guess that's why it's medium.
Yeah, fair enough. Gosh, what the heck is the problem? But see, I'm not getting a timeout error though. I'm getting a runtime error. Why would I be getting a runtime error? Should I unlock one of these? I'll unlock one of these. Oh, that's a lot of data. Big numbers. Holy jeez. So this is why it's slow. Can I save this? it's still going. It's going a heck of a lot faster on my end than it is on the stream, I think. Oh, you can't see it. Huh. Sorry, let me fix that share. I'm going to let that still do what it's doing and see if I can do it a different way. That'll work. 1.3 megabytes of data. And this is still happening, so die. Okay, it died. Cool. Let's go to that code. Try it here. Okay. So now I'm just running it on my command line. But why I want to do that is so I can time it. So that took next to no time. User 0.2.3 seconds. Oh. There wasn't a speed thing. This is where we show that I'm dumb. My scores dot get x or 0. I should have known because it didn't say it was a time error. So on my map or my dictionary, I'm going to get the value of x, and if it doesn't exist, I'm going to get a 0. We got it, yay! What do y'all think? I am